All right, we're rolling. So we're going to continue on. So the other day we ended with what? Square roots and scientific notation. Okay. What did we say the square root symbol was equivalent to? What exponent? To the 1/2. So it's the same as raising something to the 1/2. Now, and what question does it ask? What question does this ask? When you see a square root, it's asking you a question. What question does it ask? What positive number? Remember we went through that discussion that the inside has to be positive, or the answer has to be positive. So now when you see this symbol, there we go. What question does this ask? So let's say we have this. It's an easy one. What question does it ask?
What is the cube root?
Yes, but what does cube root mean? What are you looking for? Can you be more specific on the question?
What positive number times by itself 3 times equal?
The inside, right? So what you're looking for a number that you can multiply by itself 3 times. Okay? It doesn't have to be positive number. It has to on this problem since it's positive. So what number can you multiply by itself 3 times to get 27? 3. However, you can take the cube root of a negative. Since it's an odd root, means you have to have something multiplied 3 times, right? So negative is okay to have cube root of a negative. So now what'd you look for? What's the cube root of -8? You would say what? -2. It's got to be a negative, right? It's got to be a negative because a negative times a negative times a negative gives you a negative. Okay? So you can take the cube root of a negative, and that's what you're looking for. That symbol asks what number multiplies by itself 3 times to give the inside. So it doesn't have to be a positive, it just depends on the question. So a cube root, you can take the cube root of a positive or you can take the cube root of a negative. Okay. All right, and then now we get into simplifying, whereas if I had the cube root of, let's say you had cube root of 64 x cubed y to the 6th. So I'll tell you how I do it in just a second, but let's see if you can simplify this. So we'll call this one example 1. That's a big cube root. Usually it's a smaller, like a little 3 there. So we'll do this part A. Part B, I'll give you another one here. The cube root of x to the 5th y to the 10th. Let's do that. Okay, because not all of them are going to come out to be as clean as you would like. So let's look at each one. Let's do the first one. See if you can get the answer, and then we'll look at the second one. Okay. Who would like to give us the answer to the first one? All right. Yep. Yes, no? Yep.
Sure.
Go ahead.
4xy squared.
4xy squared. That's exactly right. So and see, now you don't need any absolute values or anything like that because you can get a negative answer when you do a cube root. How did you come up? I mean, I think the 4 is obvious, right? 4 times 4 times 4 is 64. How did you know to do x and y squared? Well, x cubed, so x. What about the y squared? Okay, so that's right. So if you think about square root is like raising to the 1/2 power. Cube root is the same as raising to the 1/3 power. You can also use that if you want. So had you written each one of those like this, we go down here, had I done 4 cubed, x cubed, y to the 6, and then I can raise this to the 1/3, it's the same thing. And then I can use my properties of exponents that we did yesterday. Remember, when you have multiplication and you have an exponent here, you can raise each one to the 1/3. So you could do 4 cubed to the 1/3. You can do x cubed to the 1/3, y to the 6th to the 1/3. That's your dividing by 3, because a power raised to a power, we do what? Multiply 3 times a third. What's going to happen? Cancel. I'm just showing you one way you could do it. You don't have to do this. 4x, those cancel, 6 over 3, there's your 2, and there's how you get it. That's one way to get it. Or you're just looking what times what times what gives you y to the 6th, y squared. Either way you can do it. So the first thing I'm going to do is make sure that I, on part B, sort it out to where I have an exponent that's divisible by 3. Because 5 is not divisible by 3. So how can I write x to the 5th so that it's got an exponent divisible by 3? Yep, go ahead, Alex, go ahead.
3 and 2? No.
Yeah, x cubed and x squared, so you break it up. So what I'm gonna do is, I'm gonna put in x cubed, x squared, and then what could you do with y to the 10th? Y to the 9th times y. And we know not everything always moves out of a radical, right? Some things have to stay inside. So now the ones that are divisible by 3, I'll move those to the front. These two are going to stay in because they're not, it's it'll be like to the 2/3. We don't want to do that. So we'll leave the x squared and y in. The ones that are divisible by 3, I'll move to the front. Let me erase this here. Okay. So we would say x cubed, y to the 9th is in the front, x squared, y is in the back. And now both of those, you can do cube root. Cube root of x cubed is x, cube root of y to the 9th, y to the 3rd, like Molly said, divided by 3. And then the other two just stay in, and there you go. And that's how you do it. Okay, does this ring a bell? Okay, like I showed you the rule yesterday, the product of radicals can be written as one radical. So like we said, square root of a times square root of b equals square root of a times b. That goes hand in hand. I could do the same thing here. If I had cube root of 2 times cube root of 4, we're like, I don't know what that is, right? I don't know cube root of 2. Does anybody know cube root of 2? I don't know what it is. However, if you make it one cube root, it's cube root of 2 times 4, which is 8, and now you can answer it. What's the answer? 2. So it's good to know those rules. Okay? So that's it. So you'll get some problems like this, simplifying. And then I'm not going to keep going on, but you have 4th root and 5th root and so on. And then you're looking similar problems. But that'd be part of the review. Any questions about that? Everybody's okay? You understand why you can take the cube root of a negative? Okay. All right. Polynomials, your favorite, correct?
Yes.
All right. Okay. So we'll call this example 2, part A. We'll just put simplify. All right. Okay. What would you do? How would you simplify that?
Distribute.
Yeah, so we talked about yesterday working inside out. There's nothing you can do in each of the parentheses because there's nothing you can combine. They're all different terms. However, here you could distribute the -2. And after you distribute, what's that sandwich I like to eat? Chicken, lettuce, tomato? What's that stand for? Combine like terms. So yeah, that's all you're gonna do. Distribute, don't forget about the negative, and then combine like terms. Should take you 2 seconds. There you go. Get done with that one. Move on to the part B. Where are we at? We're gonna get out of this class. 11 something.
Is it 11:19 or 11:24?
So 11:19 is cleanup, right? I can't remember. We'll be done in 20 minutes. Okay. Ready? Krigo, you ready?
Yes, sir.
Okay. What did you do first?
I boiled it.
Well, you just distributed it, right?
Oh, wait, are we not?
No, we're doing this one. This is the next problem.
Oh.
This one here, let's finish this, we're not done. You did this one, right?
I did, yeah,
Did you finish the problem?
the whole problem. I did,
So, let's make sure we're clear.
okay.
When simplify means, it means to get it in what form? Smallest form, right? To reduce it as much as possible. Notice we're gonna have like terms, an x cubed and an x cubed. So the reason we want to distribute this -2 so we can combine those terms, right? So on this distribution, we'll worry about this one. I'm gonna erase it for now and add it to the bottom. You have it written down, right?
Yes, sir.
Okay, so distribute the negative, usually I put the next problem because I don't want you to just be sitting there. You can get started on the next one when you get done. So distribute the -2, what did you get? Negative 10x cubed, make negative 38x plus 8, right? And then here, you got your 8x cubed minus 7x squared minus 11x plus 14. Then what I usually do is I highlight or underline. See, I do something so that my eyes go to those guys, okay? So now I've kind of highlighted the cubes, okay? And make sure you leave the door cracked because it's locked. What do you get if you combine those two?
You get -2x cubed.
Negative 2x cubed. All right, I move on. That's the only x squared, so I'll put it. Then I've got negative 11x and negative 38x is what? -49x, and then I've got a 14 and an 8. Positive 22. And now you've simplified that polynomial expression, okay? You're gonna tell us how to FOIL now. Okay. Got it? Does this ring a bell? Everybody good with this? Okay. So I think combining like terms and, distributing and all that's pretty simple. I just want to remember the process. Remember, this is called the review. All right. Then what were the two guys that we were gonna foil, Hannah, on part B?
So I just wrote the answer.
It's 2x minus 3
2x minus 3.
times 5x plus 2.
Okay. So let's just go through it. So she's right. She called it FOIL. First, F stands for first. What do we get? 10x squared. O stands for alter. Hopefully you know what it stands for, right? Alter, 2x times 2 is 4x. I stands for inner. And what do you get there?
Negative 15x.
Negative 15x. And then L stands for last. Negative 3 times 2 is negative 6. And you get 10x squared plus 4x minus 15x is what? Negative 11x and minus 6. That's it. So you expand and then simplify. Okay? Any questions about that? All right. All right, I'm going to erase. We'll run out of room. All right, now so what am I trying to do? It's like a video game. Who here plays video games? Oh my gosh, all you guys play video. What do you play, Mac? What video game do you play? Call of Duty? Can you get online and fight each other? Is that what y'all been doing? My son's on there like screaming all the time, my 14-year-old. He screams like these, okay. I would love to just I'm bad. I get dizzy. I can't play those things. I'm like, eh. So I'm no good at them. I like the sports games. But in most video games, like the old school games we had, Super Mario, you had levels, right? What happens as you go from level to level? Easier or harder? Harder. Okay, that's what we're doing here. Same thing. It's like a video game. We're on level 3 now. Ready for level 3, Nathan? Yeah. Okay. Can't call him Nate because I got to be all proper. You know I like shortcuts. I don't want y'all calling me Al anyway, so you can't always abbreviate, right? Okay. Level 3. Ready?
Yes, sir.
Okay. What's different now? Can you just do flat out FOIL method?
No.
No. Because what is the word for the guy in the first parentheses there? What is that guy called? If there's two pieces. Binomial. 2 terms. What is the second one called? There you go. It was not rocket science, was it? So you got a binomial times a trinomial. So real quick, you can't just do full because there's 3 pieces. But you do the same idea. What I like to do is I just take one of these guys and I'm going to do what with this negative 4x? I'm going to multiply by all 3. And then I'm going to take the negative 2. I'm going to multiply by all 3. And then what's my favorite sandwich? Chicken, lettuce, and tomato. All right, good. So you're going to take this, multiply it to all 3. Then the negative 2, multiply it to all 3. And then CLT. Got it? Now y'all are gonna be going to Chick-fil-A ordering chicken, lettuce, and tomato, because I'm making you hungry. When we do reflections, I'll talk about rotisserie chicken. And when we talk about profit, revenue, cost, I'll tell you about my fake business kebab hut, because I love making chicken kebabs. Last year's students got gypped because usually in May at the end of school, I would go to the soccer field and I made kebab for everybody, chicken kebab. So I did that the year before and this past year. Because we couldn't. Feels like you're breaking the rule, doesn't it? Don't ask. All right, Haley, you ready? And this Haley, Coca-Cola Haley, right? Uh-oh. Uh-huh. You look confident. I mean, I can really tell because of the mask there, I can really see a lot. All right, let's just go through it a little bit at a time. I'm gonna point, whenever I point here, you're gonna multiply each of these by negative 4x, all right? So here, what's this times negative 4x? What'd you get? That's the hardest one. If you can multiply that one, then you got all of them. You're good. All right, negative 4x times 7x. Negative 28x. Just remember, negative times a positive, right? Negative 4x times negative 1, that's easy. Plus 4x. Now, where is my mistake?
You squared the 28.
28x squared. Good. Very good. Now, what I'll do is this. Instead of writing next to it, I just indent, especially if it's in order, like x, no x, x squared, x, no x. I indent and everything will line up. So what I mean by that is normally you would just continue writing, right? I just drop down, and now when I take this negative 2 times 3, we're going to get what? What are we going to get? Yeah, but what's the answer when I multiply? What do we get? I just drop down and put it right under the square. Now I can combine those. They're already in line. So I indent and put them in line there. Then negative 2 times 7x, we get negative 14x, negative 2 times negative 1 plus 2, and now you have everything lined up. So I like to do it this way. You don't have to, but that's it, okay? And now, no x cubes, your x squared, your x's, then you just add everything. So negative 28, negative 6 is negative 34x squared. What do these two add up to?
Negative 10x.
Negative 10x plus 2. Is that what you got? You had it right. Okay. And that's really the limit of multiplying anything after that, now you got the idea. Okay. Any questions on combining polynomials, whether it's multiplying or whatever? We're not going to do any dividing in the review. Did you guys do division of polynomials in integrated math?
Yes.
Yeah, like long division. Were you taught synthetic division with a little? Okay. We'll get to that again, but we're not going to review that. Okay. The last thing. Factoring. Factoring to kind of help us do a couple other things, but mainly factoring. Okay. So we'll start off with something basic, and then we'll move from there and see. I will tell you this is probably the most used thing that you would do in calculus, or in pre-cal and calculus in terms of an algebra skill. You do a lot of factoring, okay? So now, let's get started with some factoring, and we'll look at some basic factoring rules. I like to just start with your basic binomial, or, two pieces, what can I factor out? So like if I have a 14x to the 4th minus 7x squared, all I'm doing is just looking to see what's in common that I can factor out. So let's start with this one. So term to term, what's the biggest piece that we have in common? We take that out, and it's basically the reverse of what? Factoring is you're doing what in reverse? When you take something out, yeah, it's kind of reverse for a reverse distribution. Yeah, who said that? Good, I can't tell because, good. It's kind of reverse of multiplying, all right? So think, I would look at the numbers. What's the greatest common what? What are you looking for? It's called the greatest common factor. And then x to the 4th and x squared, same way. What is common? And then take that out. And then I'll show you how I would work it. Okay. If you're not sure what you're going to be left with. Okay, so what's the greatest, Rayleigh, what's the greatest common number? What number does each have in common? 7, okay? All right, so that goes on the outside. What's the the variable we can take out. X squared, biggest, so I just look at the exponents, whatever's the smallest exponent, that's what I know will go into both. There's that. So now you're just asking yourself, you're thinking, there's two ways to do this, I'll show you both ways. So the thinking is here, what do I gotta multiply by to get 14x to the fourth? Well, it would be what? 2x squared. And you put your minus, 7x squared times what? Gives me 7x squared. 1. There's that. And that's factored. Okay? You're gonna say, well, why would I ever want to factor? It's an easy way when you're looking for roots or solutions. If this equation was equal to 0, now once I factor, I can take each of these guys, I can set this equal to 0 and that equal to 0, and I can get my answers. That's why it's easier if you factor. All right, now, another way to do this, just to show you, like say, well, I really have trouble kind of reversing it in my head. Well, really what you're doing is this. Once you decide what it is, so if I left this here, I'll show you real quick. Once you decide what you're gonna factor out, then all you're doing is, you're basically going through and dividing by that. And if you do that and reduce this in here, whatever you take out, if you go back and divide by it and reduce, that's gonna give you the inside. See, so 7 and 14, that's 2. That leaves you your x squared, those reduce, give you a 1. And that's how you know what you're left with. It's 2x squared minus 1. You don't have to do it that way, I mean, I'm just showing. Whatever you're taking out, essentially you divide by that, and that tells you what you're left with. Okay? Always works like that, right? If you had a 5x cubed minus, I don't know, 10x, right? What would we take out? 5x, and then I can go back and divide by 5x. And if I reduce, that's what should be left in the parentheses. Those cancel, x cubed over x is x squared, 5x into 10x is 2. So you get 5x, x squared minus 2. Or you can just ask yourself, okay? That's level 1 factoring. That's where you have you have something in common you can take out. All right, now level 2. Erase this problem. Oops. Part B. This is level 3. Still factoring. Look, the graphs still factoring. So now, all right, what is this called? It has 3 terms. What's the name? Trinomial. It's a quadratic, right? It's an x squared. So now you're doing reverse of what method? Oh, yeah, it'd be a lot if you're doing all that. We did it already today when we multiplied. When you multiply 2 terms together, FOIL, so you're doing reverse FOIL. So you're going to basically go back. You should have 2 binomials multiplied. Okay. So all you're doing is trying to do the FOIL method in reverse, and whatever you have, these 2 should multiply to give this. So it's very simple if you think about it. You're asking yourself, what 2 things going to multiply to give you x squared? What is it going to be? X and x. Those go there at the first. Now you ask yourself these 2 questions. Who knows the 2 questions you should ask yourself? There should be 2 questions you ask yourself when you factor. Here's what it is. You're going to ask yourself this. You're looking for 2 numbers that multiply to give the last and add to give the middle. If you can do that, then you have it factored. So you ask yourself these 2 questions. What 2 numbers multiply to give the last number and add to give the middle number? when you have a quadratic where the number in front is a 1, it's a 1x squared, this is how you always factor, if it will factor. If there's not two numbers, then it won't factor. There should be two numbers that multiply to give what? What number are we trying to get? Negative 28, and add to give. Yeah, if I did it right in my head. Okay. So, being able to know the factorization of a number is helpful. What are the factors of 28? Right, you know those and it makes it, yeah. So what are the two numbers? -7 and +4 is exactly right. Because you have to add to give -3, which you're right. And that's the reverse of 4. And there it is, it's factored. Now, what's the benefit of this? Again, if this was equal to 0, which one's easier to see the solutions? First line or second line? Yeah, what are the solutions? Yeah, the opposite of those factors, yeah. So that's the beauty of factoring. It's easy to solve. I'm not saying it, I'm just trying to show you what that tool is used for. That's not the question is just factor. Okay, all right, ready for another one like this? Let's do another. What level are we on right now in factoring? Still level 2, we're not bumped, we're gonna do one more level 2. I know you wanna go to level 3, but we're gonna stay with level 2. All right, level 2. Factor. All right, Colton, you ready? All right, what'd you get?
X plus 4, X plus 8.
Very good. That's it. Good job. Everybody good with that? Everybody say we got that? Two numbers that, so you gotta be good with just factoring a number, right? Where you can factor. Okay. Now we're gonna go to the next level where you have, it's not as obvious as what you're gonna do. And there's little factoring formulas that are helpful. Okay, so let's say we had, I'll start with an easy one. Okay, you could still use the same method that we're using, but this has a name. There's a particular name for this. Does anybody know what you call that? They're each perfect squares, yeah, that's right. It's called difference of two squares, and there's a factoring formula for it. So anytime you have something squared minus something squared. So anytime you have a squared minus b squared, this is called difference of two squares. All right, and it always factors a minus b, a plus b. Okay, difference of two squares factors a minus b, a plus b. Okay, so just substitute x is a, what would be squared to give you 16? 4. So it's basically the square root of each one goes in those little blanks. So how would x squared minus 16 factor?
X minus 4, X plus 4.
X minus 4, x plus 4. So be on the lookout for difference of two squares. And you could have, it could be up an exponent, it could be something like this, like x to the 4th minus 81. Doesn't have to, because isn't a 4th still a square? Isn't that something squared, right? So how would that factor?
And it's 9.
X squared minus 9x squared. And then guess what? That is difference of two squares. This one you cannot factor because it's got a plus. Now the x squared minus 9 can factor. How does that factor? Yep, and x plus 3, and then you got x squared plus 9. Okay. I'm going to just give you the other two formulas, and you see if you have a need for them in the homework. The other two are called difference of two cubes. And this formula, it's just basically once you see it, it's just basically knowing the formula. It's a cubed minus b cubed is a minus b, a squared plus ab plus b squared. This is how it will factor if it fits this form. Okay, so plug and crank into this formula. And then you have sum of two cubes, a squared plus b squared. What a dummy, that's not cubes. A cubed plus b cubed equals a plus b, a squared minus ab plus b squared. We'll do one of them. I'll do sum of two cubes just to show you how you would do it. So let's say we had y cubed plus 8. All right. So if it helps you, I'll slow down because I'm fast. When you drink coffee like I do, you write fast. Oh, this is going to take forever to upload. Almost done. We got one more wrinkle of factoring we need to do. We might as well just roll with it now. It's 37 minutes. It'll be okay. Okay. Sum of two cubes. I would change 8 to what? What's cubed to give you 8? 2. So now it's basically just this. Now it's a plug and crank. You just use the formula. In place of A, you put Y, and in place of B, you put what? 2. You just sub it in, and that factors it. Okay? So see if you can use the sum of two cubes formula. Now I got one more type of problem to show you, then we're done. Okay? I hope this thing uploads, otherwise it'll be a pain. All right, let's go through it real quick. So I'm going to use the sum of two cubes formula because that's what I have. So what would a plus b be?
Y plus 2.
Yeah, y plus 2. Then it's a squared minus ab plus b squared. So what's a again? Is y squared. Then it's going to be minus 2y. You want to say y2, right? And then plus that 2 squared, which is 4. And that's it. And that's factored. Okay. That's how you factor sum of two cubes. That will not factor. It stays. This is it, okay? So now you can see negative 2 is the solution if you were to set it equal to 0 and so. Okay, the last thing kind of is like if we were to wrap all this together, you know, what's the use of factoring in terms of simplifying fractional expressions? So the last step of this, can I clean the board? We have it. Last one, okay. And you'll get some of these in the homework where you have fractions and you're looking to reduce. So for instance, let's just say we have, let's say we've got x squared plus 5x plus 6 over x squared minus 4 divided by x squared plus 10x plus 21 over x minus 2. Okay. Ugh, looks awful, doesn't it? And it's basically, this is factoring, but this is, we're looking at how do I reduce this expression? How do we reduce it? What you don't want to do is actually do division. You don't want to divide. So what's the rule when I'm dividing by a fraction? How can I make it multiplication? Very good, flip the fraction. So the first thing I'm going to do is flip and multiply. Okay, so that's the first thing I'll do. If it's already multiplication, then I'll leave it. And I'll show you what I'll do next. So now I'm going to make this x squared plus 5x plus 6 over x squared minus 4 times x minus 2 over x squared plus 10x plus 21. So what is the rule when you multiply fractions? What are you supposed to do? That's it. I saw you. Okay, you're supposed to multiply across. However, when I see all these squares, square this, x minus 2, x squared minus 4, I'm thinking, we just looked at factoring. What if I factor these and look to reduce it? Look and see if things will cancel. Because if I have the same factor in the top and bottom, they can cancel. And then therefore my work becomes a lot easier. So the next thing you're going to do is after you flip and multiply, look to factor and cancel. And then it should be a much easier problem. So now take what you've just learned from factoring, factor each expression that you can, and see if it will cancel with anything that's diagonal or below it or above it. And that's the last bit of the algebra review. At 43 minutes. About to see if it will upload. Okay, so just because I'm at almost 45 minutes of film, let's see if we can just kind of go quickly. Spencer, how did x squared plus 5x plus 6 factor? What did you get?
X plus 3, X plus 3.
All right, so that's x plus 2 over x plus 3. What about below it? X squared minus 4, what's that called? Difference of two squares, how does that factor? Very good. We got that. The x minus 2 up there, you leave alone. If you want to put parentheses, you can. And then how does x squared plus 10x plus 21 factor? All right. Now this is my favorite part. This is where I just Zorro this thing. All right. Right? What can cancel?
X plus 2. X plus 3.
That's it. 1 over x plus 7. Don't forget there's a 1 on top. Bam. That's the pre-cal, that's the algebra review. We're going to stop this lesson now because this is a long video, and do your work in